Pawan and Subbu, welcome. Let's
Yep.
focus.
Sure. Yeah, welcome, Pawan and Subbu. Yeah, I just started the recording. Congratulations, Prasanna, clearing the associate certification.
Thank
Can
you.
you just talk a few words about your experience?
Yeah, sure. I mean, like it- sometimes, like we plan to do, but until you get to a point or you get some motivation, you will not try it out. So for me, like my yeah, like told it seems like I need to do certification, so I did it in 1 week. So all I can say is like I don't work hands on this day in day out because I manage. I have the team who does it, but all all we need to do is like just understanding the concepts and then going through that. And definitely if you have some programming background like Python or SQL, I think SQL generally we know how to grant, how to like select statements, all these things. So this will definitely the concepts which you learned, we just need to like relate it, how does that will apply to that. And we have like in Databricks itself, like you have one course where they will explain like all the concepts and all. So the problem with certification is, right, you do hands-on and you know what to do and all in the UI because you don't remember like what actually the value means. You just go there and click on like where do you check the job is running and all. But here the certification, they will check where do you go, that kind of questions they will also, you need to give the minute like details also, you need to sometimes understand. It's not hard, it's not easy. So it's like first first decide one date or like have some target time and then like go for that. Okay, so it shouldn't take more than a week or 2 weeks. If you're new, I would say 2 weeks you can spend on that. You will be good. We have a lot of material in the YouTube, like I keep, when I'm doing work, I'll parallelly listen in the YouTube also some of the videos. They keep explaining some of the topics and all. And we have some practice questions also, like some of the practice questions you have to go through that in the YouTube also. People really explain like each question and answer why that answer matches to that and all. 5 to 10% sometimes you have conflict answers what you learned and what it shows, but more majority of the time it definitely helps. So go through the YouTube, search for associate dumps in the YouTube. A couple of links I can also share. They really explain very neatly. It 50% comes from that, but 50% definitely you need to go through the topics and whatever like Harun explained or in this recordings, right? If you just listen carefully and then try to practice, we can clear it easily. It's not that tough, but all we need is like we need to fix some date and we need to have a target, and unless that is fixed, it will still postpone to get the certification.
Absolutely, absolutely. Thank you so much, Prasanna. Absolutely, that was really motivating. So, I would just like to, I spoke to a couple of people who reached out to me, Subbu, Hari, right? So this is the first step you want to take. Fix a date, as Prasanna said, and then start practicing. Once you get starting the certification, it'll give you a lot of confidence, right? Rest on, there is another level, next level certification that you can do. But for beginners who do not have hands-on experience or who are coming from other streams of IT or non-IT or business, the associate level certification will be a great boost to your confidence. And it will be very helpful also to get established, recognized in the market for anything to start with. So I encourage people to get started with this, though the goal is to do professional certification, but this will also help you to get started and have a confidence with. So
does the certification ask for syntax or just the concepts? PySpark or SQL syntax and
yeah, most
or just the concepts?
no, mostly it will be concepts, but there will also be some kind of syntax like fill up the blank or what function do you use here, that kind of some questions, multiple choice you will have. You don't need to write the code and execute something like that to get the result, but it'll give you like, if you want to say something like aggregation, for example, say they want to see the aggregation of the quarterly sales, what do you use? So something like that in SQL, right? So we use group by function.
Right.
Or aggregate and then group by that. So those things, same, those concepts, they'll ask you.
Got it.
There are some sample test papers. We'll share it to you. I
Definitely.
think.
Okay.
Yeah.
So, Prasanna, there is that group, right? Probably you can share the resources, what you have gone through, some information there for people to go through. I will also add some more resources in the group, so people can get started on that. Okay. Thank you, Prasanna, for letting us know your experience and motivating the team. Yeah, today, so I'm going to discuss a couple of topics. The first one is JSON files, how to parse the JSON files. So we have been working with the CSV files till now, and then also how to generate some sample data within the notebook to convert into data frame, how we can do that using range and all that. So there's another data source, that is JSON files, which is very popular in the IT field. In the source, most often or not, you get the JSON files as inputs to process, and then we'll also have some nested structure in the JSON. So that we'll go through and see how we can parse those. And also a small topic of UDF, user defined function, how we can use that function, our own Python functions to do some processing within and use those functions in the transformations if you want to do. So these are a couple of topics I want to share today. And if you have some time, people can share, whoever wants to share their work, what they have practiced, about 10-15 minutes, if anybody's willing to share. We'll see based on how we do with the time. Okay. Yeah, let me start with this. Okay. So first I will start with a JSON file. You can see here the structure. So basically, so you have seen CSV files, right? CSV file is all the data in one row, basically. So it's kind of a flattened. But if you have data coming in which has multiple entities, right? So not just the customer data, maybe it has orders data of the customer, it has address of the customer, everything. So instead of flattening it everything in one line where you have multiple orders, so you are not flattened in the CSV. So you can have it in another format, JSON format, where you can have all the attributes and the entities, sub-entities also in the JSON representation. So you can see here, so this is one element. So each element has, say, something like, the column header, you can say in CSV, and the value. It's kind of a key value pairs, you can say, right? And Python, it's more like a dictionary where you see key and value. So key is ID here and value. Name is ID and this is value. Attributes is ID. And then value is again a dictionary or a struct element. That's what we call in the PySpark. So the key is string, the value is a struct. And within the struct or a dictionary you call, again, you will have individual key value pairs. So you have a key value, hair color, eye color. So this is the representation. So this is one record till here, then separated by a comma. Then this is the second record. So here again, you repeat all these elements, attributes, hair color, eye color. So you can still have nulls. An attribute can have, have multiple records. And then within that struct, you have multiple elements. Sometimes you will get more nested. For example, here attribute is only one. So you can have multiple attributes. For example, if it is orders, or line items. So order will be one, but you'll have multiple line items. Then it comes in as an array. The concept of having multiple items within that comes in as an array. So if we just look at this file here, so this is another JSON file, right? So you have same thing, ID, name, age. So these are elements, the first row. So you see here, so till this part, this is one record. This is second record. So basically we have two records here, two IDs, ID1 and ID2. Within that, if you see, there is an address. Address, again, flower brackets is just a structure or a dictionary where it will have only one. City, state, and zip are elements of the address. But if you see here, address is a square bracket, which is an array. Array means you have multiple elements. If you see here, 1, 2. So in orders itself, again, you have two elements. Okay. And each element is again a struct. So in that you have order ID, product quantity, first one, order ID, product quantity, second one. So this is a nested structure where you have a struct and you have an array of struct within this. So like this, you can have multiple nested. So there might be another array within this struct. There might be a struct within array. So it can go on nested structures. But once you know how to parse a level 1, level 2, you just keep on going, doing that for the nested structure. But to write that, so there are two things. One, the different ways of parsing it. But first you have to know what is the structure of the incoming JSON file that you are going to parse. So based on the structure, you will write how to parse that JSON file within your job. Okay, any questions in the file itself?
So my understanding is like if you take a table, there is different columns, and the structure, what are you talking about? Say address, right? You're inserting the data inside it. Say the blue ones is like a table fields, and the data is in red. Is that?
Yes. Yeah, exactly. So these are headers or column names, and these are values. It's a key value pair.
Yeah.
Right?
Okay.
But here, what you're doing here is you're having all the entities which are related to each other together.
Yeah.
In
Instead of insert commands, we are putting in an array format here.
No, we are not inserting anything here. It's just the representation. So
representation.
What
Okay.
is the difference between CSV and JSON? In CSV, you get all in one row, right? We have seen.
Correct. Yeah.
Right. So you have a text, you have, so this is, so this is the CSV. Now I have a header here, ID, experience, age, gender, salary, and then you have each record in one row, right? But here in JSON, it is split into multiple rows. All the data is not one row. First thing. Next, it has both the ID, person, whatever attributes, plus child records like address and orders. So it's like a parent and all its child together in one block. So this is one record. So in one record, it has all the information. Normally in CSV, you get one employee CSV, one order CSV, one address CSV, different files. Of course, you can flatten it and put it in the same CSV also. Writing, it can go on adding columns till the end to add address, to add order 1, order 2. So if you have two orders, so how did you write in the CSV?
So I think it is ID is if you have the same comparison, right? Like what he told about table, ID is the primary key, and it will have with the same ID you will have multiple table records, right? if you have multiple addresses and each one will have multiple orders and stuff like that.
Exactly. So basically, when you write into our SQL representation of parent-child relationship, so ID will have, say, let's say this is person. So this will go into person table. And if we have an address, this will go into address table with same person ID. So address will have its own unique ID. But if you see here order, it will have same person ID, but order ID will be 101 for one first record. It will be 102 for the second record. So if you go to orders table, it will should have ID 1, order ID 101, then details, product and quantity. The next row, it will have ID 1, order ID 102, and product quantity. So that is the end state of how we should be transforming this data into when you parse this. Then you will have ID 2, order ID 103. Address will be there and address order ID will be 103. Suppose if you have more orders, 104, 105, then it will have more rows in the end table. But we'll see when we parse that, how it is parsing into the next, when you get flattened into one row, all this data or multiple rows based on the structure. So I want you first to understand, people who are not familiar with the JSON structure. I want them to just have an understanding of how a JSON looks like and what it means in terms of data, right?
If you want to add more fields, you just add more line items.
Yes. So if I have another order, I can add another order here. Just put a comma, put order, 104.
No, say within that order ID 103, the product, other than product and quantity, if I want to have a color and other properties, I
Yes.
can keep adding those line items, right?
Yes.
Okay. Okay.
But to keep the terminology correct, Nag, they are not
Mhm.
called line items. Okay. So
Oh,
those are just attributes.
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 Line item
Okay.
means, suppose say you go to a shop,
Mhm.
it's the same order. You give a credit card. But
Mhm.
the line item is you got a shampoo, you got a soap. Each one is a line item. Right?
Okay.
So each order is a line item. That is line
Okay.
item. So big one is the ID. Main ID is the order ID.
Mhm.
Then below order ID is the line item ID. Actually, right?
Okay.
First ID is the customer ID.
Mhm.
Below one is for the is orders. See, sometimes you may have many orders. Then each order can have its own line items. So it's a different way of stacking, representing.
Okay. Thank you.
It will go on, you can do 1,000 orders, million orders in this JSON. So this whole file has all the schema and all the data. That is the beauty of JSON. If you send it to even India, to someone, they open it, they understand what is this means. Right?
Okay.
So someone convert this into a table. If you see a table, you understand the structure, right? It has a schema and it has data.
Yeah.
But since this is not table, you put into the file, but it has all the metadata, like the schema and also the data. Correct? Whereas if you take what we call the Parquet, you can't open it. It's a binary file. It's a you can't human. It's not human.
Yeah, it's not readable.
And CSV is all strings. CSV is. Whereas JSON is a very common way of exchanging in the transactions, like XML. XML is also one of it. So I think let's go. I think there's a lot of theory. If you start seeing it, it will be easy.
It will be clear, yes.
But good introduction.
How you are matching the schema with the structure of the file, right? So yeah, let's head back here. So first thing I want to show is a simple JSON file. It's like don't have structure, but this is, you see here, it's just one record in each row. Okay, so it just has name, age, city, just like a CSV, right? And this notation, you will have the key value pairs. So that will just parse, this is one column value of all of these rows. So that's the simple file. I'm taking this here, simple JSON file, and I'm reading this spark.read.json. So just like you did .csv, it can also read .json file. Okay, and I'm giving this file path, a simple JSON, and display this data frame. Okay, so you see here, it has parsed to these column names, age, city, and name from the file.
How did you put that? Put that thing in the DBFS?
Yeah, here in the JSON files. So just go catalog. This is the hack that we have shown. You go here and you can upload right here, whatever path you want to give here. So I gave, let's say, JSON files here, right? That's the path. I can just, so JSON file /. So it will create this directory under this. And then whatever files you add here will go into this directory.
Got it.
Okay. So this is what we did last time. So if we go here, the path is tables JSON files. There I have uploaded this simple JSON.json file. And then I'm reading it and display the data. So it has taken this column names here, all of this, and it has done the display. Parsing, simple, right? Now, there is another way. So we have let the Spark read the file and understand the column names, and all of it, it has already made sure age is long, city is string, name is string. Because if you see here, we have put names in quotes and age just as a without quotes number. So it has already deducted that age is long or integer, and name and city are strings. Okay. The same thing, you can also enforce your schema. Like last time in CSV also we did. We can provide, when you have a data as list, and then you have a schema, you can create data frame. Remember we did in our previous classes. You can give data and schema. Either the data is created within the notebook, or you're reading from a CSV file or a JSON file. You can actually enforce the schema. You can provide the schema here and say struct type of what are the fields and what is the type of the field, integer, string, string. So basically it's the same thing. You will get the data frame with name, string. Age, you see here, integer, we have given integer type. Now it is integer, it's not long. Okay, whereas when it is automatically deducted, it gave a long type. Basically, if you want, you can also do long here, data type. So this data type and fields, you can enforce and read the schema, enforce the schema and read the file. Okay, is this clear till here? Reading JSON file, value pairs.
Harun, in the struct type, does the order of field matter, or like, because can you scroll a little bit? Here we have displayed age, city, and name, right? The data frame structure.
Yeah.
Here it is name, age, and city. So
we have
when
given
you
the
define
name,
the
right?
schema,
It will match this name.
okay, in the struct type, so in the schema, the order of field doesn't matter.
Doesn't matter. It will match this name and its data type.
Okay, okay.
And then it will take. So you can see the data is still same, right? Name column, you got all name values only. Age.
Yeah.
Yeah, that's good. Good observation. Okay, so next we will move on to the next level. So that was one flat line just having 3 elements, right? So now we will go to nested JSON, but with simple structure. Okay, so what is that nested JSON with simple structure? Is this one, nested JSON, but it does not have arrays. It just has elements, struct type. So ID and name, then it has something called attributes, which is a struct type. Within that, again, it has 2 attributes. What is hair color and eye color? First record. Second record, ID, name, attributes, hair color and eye color. So when we read this, okay, what does it show? Where is this? That's fine. Okay. So here, if you see, there is another option that we have to give, multi-line. So if you see here, our JSON is a multi-line. So each record is now distributed across multiple lines. It's not just one line anymore, right? So you have to tell Spark that my record is distributed across multi-line. So when you give that option, so you say read option multi-line is true, and then we give the JSON path and show. So when I read this, see here, ID, it has read as long, name as string, but attributes is a struct field, which means it will have again fields inside that struct. That is eye color, which is a string, hair color, which is a string. Now, if you see how it has read the data, okay, let's say display. Here, see, it has read the complete structure in the attributes. Okay. ID it has read properly, name it has read properly, but attributes, it has just taken the entire this part and written in the attribute section. It has identified it as a struct in the data type, but it still has written the entire value here. Now we want to split this into columns, different columns, right? So we don't want to write as a JSON. So end of the day, we want each attribute separately in a column. So ID, name, and then John Doe's eye color is blue, hair color is brown. So these should be in different columns. So what we have to do, we have to split this into multiple columns, eye color and hair color, right? So what we do next is
remove the truncate also, so that it would be confusing.
No, it's just to show the entire thing here. It doesn't make any difference. If it is just showing half of the column, just to mention that show us the entire value, we just use that option. Truncate is false. It doesn't make any difference. It's still same, right? Guys, you got this? How it is reading based on the struct attributes. This is a struct, and inside eye color and hair color, the entire thing, it is here. So if you
so it read automatically.
Yeah, if you drop down here again, you see it is parsing eye color to blue and hair color to brown. This one.
So it did automatically, right, Harun?
Automatically. Yeah. It has deducted automatically and read automatically.
So
Now,
earlier this is not there. The complex structure is not there. I think it's a simple file earlier. What you
yeah,
have done.
earlier this one is simple. Name, age, city. So it did not have any of these structures or arrays or anything. There's a
These
simple
are called complex data types.
yeah, nest or it yeah, complex data types, which is struct and array. Right? Nested JSON, we call it. Now, how do I split this struct into these two different columns? Okay.
Arun, can you go back and summarize that just briefly? Like how this, just summarize in brief words.
Okay, sure. So if you go back to the file here, so in the JSON file, so I have two records basically. Okay. ID1 and ID2. So ID1 is the first person, John, and he has two attributes, hair color and eye color, which is brown and blue. And we have put it in a block called attributes. So this is so here you can have more attributes if you want, right? You can have height for that person. Okay. Then you can have weight of that person. So these are attributes. You can keep as many attributes you want to this. Okay. And then same attributes here also. This is the second record. Now, how we are reading this is when we are reading, first thing we are saying is my JSON has records across multiple rows. It's not one row straight, like first thing. And then we read the entire JSON. So it has automatically deducted the data types. It said your ID is long.
Yeah.
And your name is a string. Okay. Your attributes, it said, is a struct, is a structure. Has elements in it. So it said your attributes is a data type struct. Struct means which have again elements inside that. It's a complex data type. Now inside that, what elements do I have? It said you have an eye color and hair color, which is a string of data type.
Yeah.
That's what it has read from the structure. Now the data it has parsed, ID and name are straightforward. One-on-one it has parsed. Attributes, it said, is a struct. So it has put the entire structure inside it, the hair color and eye color thing. Into this column.
Yeah.
Now we want to break it out into different columns. I don't want all together in one column because it doesn't make sense. Attributes in a JSON notation or in a dictionary notation of key value pairs.
Just to add one point for Nag. Yeah. So Nag, if you see, that is, it looks like a table where ID and name, but the attribute. But if you see the attributes column,
it has multiple
but
values.
A dictionary, right? It doesn't look like a traditional table, right? For you?
Correct. Yeah. No.
That's what he is now going to flatten it so that he is going to look that and explode it to some how to do it. Finally, we'll bring it as a tables, flat tables.
Yeah. Okay. Yeah.
Here,
keep going.
Drill down. It will still show just like your file, right? So hair color, eye color have two attributes with values here. Different representation of this. Just drill down, just to view properly. Now, I want to bring this out, eye color and hair color, as different columns. I don't want it in this one attributes column notation. So what I do is, I will select ID and name, and then it's a complex data type. Then I can use attributes dot hair color, attributes dot eye color. I can select directly attributes dot hair color, attributes dot eye color as columns, and then I select from here. So now it is, see here, ID, name, hair color, and eye color. So let's use display, it will be much easier. Okay, see here, I'm selecting ID, I'm selecting name, and then I'm selecting a column, attributes dot hair color. So it comes out as hair color. Attributes dot eye color. It comes as eye color. So for one, John Doe, this is one John Doe. Eye color is blue, it came here. Hair color is brown, came here. So you're here splitting the columns. Okay, this is at the level 1 basically, where there is only one attribute section for each record. Okay, there is only one attribute section. There are no multiple attribute section here. Inside the attributes, you have two attributes, eye color and hair color. So how
Can you also change the name of the columns too? Here?
Yes, definitely. Yeah, we can do. So column dot yes. Just say hair dot alias eyes. That's it.
Cool.
Right?
Yeah.
You're just renaming those columns. Attributes dot hair color as hair, attributes dot eye color as eyes. Okay. Now, so this is the just reading and splitting, right? So then now you have a proper tabular column. DF out. So once you have this, now you can actually write this to your database as a table. Correct? Then it will be like you have read the JSON, parsed it, and you're writing it to a database table with these columns. That is the end-to-end. You ingest data, transform it, rename your columns, whatever you want to, do calculations, whatever you do, and then write to database. Done? Any questions before we move on to the next level? Everybody's clear?
Tim, just follow the steps. See, this
it is clear.
It is not the end. It is only a beginning, because Arun is slowly taking you to the next level. First, understand this lesson. When you read first one, it looks like this. Next, he given a complex structure. Then he hard coded there, like column, etc. Then he will go and try to explode it automatically. Like that, he is taking it step by step. So that's why he just try to understand and, oh, okay, hey, till now we understood. We don't know what is next. Something like that. Focus.
Yes. Okay.
Go ahead.
Now, let's come back to this JSON. So now you can see this is the first part we did in the first simple JSON, ID, name, age, right? When we go back here and we read this, something like this. It may not be the same, but just age, city, name, right? Just 3 straight attributes like this, correct? First part, you guys are?
Yes.
Got it? Right, okay. Next, address, see here, is again a struct.
Struct.
Correct? Yes. So this is same thing that we read here, the struct like attributes, hair color and eye color. So we are going to break this address into city, state, and zip, right? Now again, you see address is only how many addresses this ID1 has here?
One
address. How many addresses ID2 has?
One address.
One address. So basically, if it is only one, it will be in the struct. Okay. How many orders does this have?
Two.
So it is not a struct. It's basically enclosed in an array. You have multiple items, it will be an array, right? How many orders here? Basically, it's one.
One.
Plus 2, it is an array. It can have 1, it can have 2, it can have 3. Basically, it is one or many. Or
Array or array of structs?
Array or list? Is that list?
Yeah, it's interchangeable. It can be an array or list. In Python, it's list. In Java, it's an array. So they are mostly interchangeable. It can be used.
Okay.
Array of struct, yes. So this is an array, but inside that array, each order is a struct, right? Here also, it is an array. Inside that, each element is a struct again, right? You got this?
A struct means a simple data structure in C.
Yeah.
So if you don't know C, that's okay. It's nothing but a structure. Struct means a structure.
So
So
basic, so same thing. See, you have seen address, right? This one.
Yeah.
Okay. Let's say I have two addresses. One billing address and one shipping address, right? So how would you do that? Then, so I would say I would change this to an array. Okay. I would change this to an array. Now, because I have say, I'm saying I have more than one address. Okay. Now the first one here, what I will do, I will just add, say, let's say address type is billing. Okay. Now I can add another address basically here, and I can say shipping. So since I have two addresses now I put it in the array, but inside it is still struct. Each address is a structure.
It is a container. Structure is nothing but a container that has similar
Some information and
yeah,
attributes of
it is a container.
Yes.
that's a good point, TK.
Okay, got it. Any questions? I mean, confusing?
No, read it. If they see, they believe it.
Let's get back. So now, I'm reading this nested JSON. Again, multi-line is true. Okay. I'll just say display. Okay. Now look at the structure, how it has read. Age, ID, name, and age, or long, and string. That is, you see here, ID is long 1, age is 30 long, name is string. Okay. Now, so this, okay. Address, what is the address type? Anybody? Prasanna?
Struct, right?
Struct.
Yeah. So address is a struct. So if you see here address, it's read as struct. Now inside the struct, we will have what attributes?
City, state,
State and zip. Each of it is a string. So if you drop down, drill down under this structure, you will have city, state, and zip. Now orders, as we said, it can have one or more. What is the type?
Array.
So it's orders is an array. Now inside the array, what you will have?
Order ID, product quantity.
What is this?
Structs.
Struct.
Yes. So it is a struct. It does not have a name, so it just put element. Okay. So it does not have a name here like this. Okay. So it just put element, which is a struct, and under the struct, what do we have?
Order ID, product quantity.
Order ID, product quantity. So order ID is a long, product is string, quantity is long. Since it is an array, this element can repeat multiple times, this structure. That's what it means. Okay. Now, when I am say display, whatever it has read. So see here, the first part, age, ID, name is here. What we are doing in the structure, we have city, state, and zip address, city, state, and zip within this notation. Now, if you look at orders, you see here, it's again still an array, right? So in the array, okay. So in this array, I have two elements, 0, 1. 0 is this 101, 102. See here, again, if you drop down, it will neatly show us array, first element 0, order ID, product ID, quantity, and then order ID, product and quantity, 102 at 1. Here also it is an array. If you go here, so only one element, 0. This is the order ID, product and quantity. Okay. Now we have read the JSON. We got all the elements. We got struct. We got arrays, but it is all in this format. We want it all in a beautiful flattened table format with each column, right? So what are the columns we are going to have? Age, ID, name. And from address, what columns we are going to have?
City, state,
City, state, and zip, right? And from address?
You mean from orders?
Yeah, orders. Sorry. Yeah, from orders, what?
Order ID, product and
Order ID, product, and quantity. 3 columns. Basically, again, it's the same record. So we don't need to have 2 order IDs, right? So order ID is a column. This is all data. So basically, it's 2 orders. So it has to go into 2 different rows on the same column. Correct? So that is what we have to do. Now we'll go back. First, we will deal with address. Okay. So what is address doing here? Address, we said we can read with column address dot city as a city. State, we are reading address dot state. Zip, we are reading address dot zip. Drop address. So basically, what if we don't do this? I will just take this out here. This is the second part. Okay. So df flat dot display. Okay, see here. What did I do? Age, ID, name is still there. Address is still there. Orders is still there. Now here, city and state. City, state, and zip. City, state, and zip, right? So I have added 3 new columns. And I'm basically reading it from this structure. Address dot city, address dot state, address dot zip into these columns, right? Now I have all this data in independent columns. So I don't need this data. It's just redundant, duplicate, right? Here, this address. So I will just drop the original column address. So I think one of our previous class, I think DK asked, can we drop the columns? I think I mentioned you can just select, but sorry for that. Still, drop is also there. You can just drop column with the column name. So you can drop the address so that you don't need that anymore. So it's just age, ID, name, orders, city, state, and zip. So the first part is done. This part we have handled.
Earlier, you didn't use with column, right? In the previous example, where it is just we have structure, no arrays.
It doesn't have attributes.
You can. So it's basically different
way of doing
yeah,
things,
way of,
different
yeah,
syntax.
different ways of doing the same thing. So I'm selecting columns here. I'm saying
Yeah,
column,
use the COL. Yeah.
column of this, right? So it's creating a new column here. It's the same thing. Here you are just adding. Select means you have to select all the columns. If you don't select this, it will only give you these two. Here with column means it will give all the existing columns plus it will add this column. You're just with column means you're just adding a new column. Select means you're selecting all the columns from the, whatever you mentioned from the UDF that will come. Okay. So with column city as address.city, state as address.state, zip as address.zip. And now I am dropping the original address column. So this first part is taken care of. Now address is already split. Okay. And since this is only one-on-one relationship, right? It's one-to-one relationship. So you get one row for each record ID, since there is only one address. It's just a structure. Now the next part is splitting the orders. So order is one to many here. So this is two orders. So when you split, you have to have orders in different rows, order one and order. So how you do it is, so you do function called explode. So you are exploding this orders, which means if you have multiple elements in this, it will write the entire row for each value in this. Understand? Duplicate. So it will write all the data, ID, name, city, state, zip. In the first row, it will take this element. Then it will again write everything, ID, name, state, city, zip. In the second row, it will write this value. So if you have 10 elements in this, you will get 10 rows for this ID. That is called exploding. Okay. So let's see that. We will just take explode here and then go to next. So I'm exploding this df flat dot with column order, explode orders, drop orders. So let's say I don't want to drop orders right now. I just want to keep that as well. Okay, see here. Age, ID, name. So here you see, now it has two rows. Okay. This is the existing orders column. It will be as is. It won't change. City, state, zip is also same for that ID. Now I have exploded it as order here. So the first one, order 101 is here. Second one, order 102 is here. Two rows. Okay. Now this information is split into two rows. This is duplicate and redundant data. So I don't need this. So what I'll do is I will drop this original column. So I have age, ID, name, ID 1 with this. This is the order. Again, ID 1 with the same, all this information. Order is 102. For ID 2, all this information is same. Order ID is 103. Now see, now we've got to a stage where this is again a, what is this?
Explode order ID.
That is a struct.
Yeah. So
That
now
is a struct.
from array of elements, we have exploded it to struct for each element. Now we go back and do the same thing what we did with the address. Now we split this into individual attributes. Okay, so here with column, what am I doing? I'm splitting this order ID, product, and quantity. Order ID is order dot order ID. Product is order dot product. Quantity is order dot quantity. And then I'm dropping the original column, this column order, because I don't need this anymore. So that is my final. Now, this is our end state table, which has all the information from the JSON. You take any ID, ID 1, age, name, city, state, zip, order, zip. All this information is same in row number 1 and row number 2. But order is different. So it has two orders. 101, laptop, quantity 1, 102, headphones, quantity 2. And then ID 2, you have age, ID, name, city, state, zip, everything same. Order ID is 103, product and quantity. So this is the entire information that you have parsed from the JSON table. This table. This entire information is now parsed into this structure. And this you can go ahead and write to your database. Now where you can do select, you can do number of orders. It will give group by orders. It will give 2 orders for this ID. It will give 1 order for this and so on and so forth. So this is the step by step. Now you will have more deep nested JSON structures. Okay. So within this order, for example, let's say you have order line items. So it will again be an array, right? So within this order, you can have an array for each order line item. Order 101, product, laptop, quantity 1, and then it might have line items. So in line items, you might have, let's say, an ID for the charger, an ID for the laptop case, one line item, and one line item for the accessories or headset that comes with it. So each order can again have multiple line items. Then what you will do, again, you will have an array within each order. Then again, you have to go and explode that and split that. So that's how it keeps going on in the nested structure until you have flattened the entire hierarchical structure. Got it? A struct can have arrays, arrays can have struct. That's it, simple. So that's how the nesting goes on until you end up with the flattened structures, columns. But basically, once you know, if you have a struct, you just split it using dot notation. Field name dot, the inside whatever field. If you have an array, you first explode, then you get struct, and then again you split with the column names. That's the 2 basic rules you keep repeating to flatten the structure.
Question to Nag. Nag is there?
Yeah.
Yeah. Did you observe, Nag? Now the table looks like your traditional tables, right?
Correct. Yeah.
So the whole table is captured in if it is captured in a CSV file, it would have been a row. Each row will have its own, right?
Correct. Yeah.
Whereas when it is captured in JSON, so they don't repeat age and ID. See, here in the table, it is repeated age and ID.
Correct. Yeah.
The JSON is a hierarchical representation of it. So you only mention once age and ID.
Okay.
And for that ID, for that person, this is the address. And this person has this many orders. Since the orders are many, right? So Harun put it under an array.
Correct. Yeah.
Now what he is saying is, now it has order ID. So it means, see, order ID 101, he got in some Ross. Maybe order ID 2, he just assume, say, Harun is working for your company and he got this information. Order ID 2, he got in some other shop.
Correct.
But order ID 1 has, again, line items. A 101, not only laptop, then item ID. You will use item ID. Order ID will be, again, an array. right? So you will have another parent, just like our parents, children, we have children, right? Like that hierarchy. But in every time, whenever you see that particular array, array is an array of structs. So he is exploding.
Yeah.
When he explode, that particular word is explode, immediately if you see the table, it became multiple rows.
Correct. Yeah.
After explode, but that is not done. You got multiple lines, multiple rows, but still that struct is there. That's why he again went and got it. To get that, he used a dot notation. That is easy. To get it, dot notation is easy. But before you get dot notation, you have to explode that array. Right. So beautifully shown. I think, Harun, if you repeat it, I think it will consolidate for everyone. Or someone comment. DK, how does the sound, DK?
Yeah, it is. One quick question I have: if the structure attribute are missing in some place, will it take them as null, or the parse will fail?
Yeah, it will fail if you don't enforce, but you can give the option when you give the schema. You can give whether it is an optional field or a mandatory field. So that is why when you mention the schema, it will go and do the validation. You skip if that value is not available for that particular. Yes, that option is available to set that. We can actually test that. We will do that. We will check that. But first, let us consolidate what we have learned with the JSON, right? So we will go back to reading this quick recap for this JSON file. So it has an first to see here. First, it starts with an array only because it says this is one record, ID 1, and this is another record, ID 2. So the entire JSON, first thing, it starts with a array here. It has 2 records, okay? And in that, the first record we have is an ID, name, age, the header data. Then we have a struct called address. And within the struct, we have 3 attributes, city, state, and zip. And since it is a struct, it will only have 1 element per record. So for ID 1, you will only have 1 address. Orders is an array, which means it's a one-to-many relationship. One ID or one person can have 1, 0, 1 or more orders. Okay. So this is first order in the struct, and this is the second order. So this here, the orders element ends, and this is the first record ends. From this, again, it starts the second record. Same ID, address, and orders. So parsing this here is we set option multi-line to true. And then when we read this file, it will first give us the structure of the data frame, schema of the data frame. The schema says age, ID, and name are attributes. The data type is long and string. Address is a struct with attributes city, state, and zip, which are all strings. Then it has recognized orders as array, which will have multiple elements, and each element is a struct, which is order ID, product, and quantity. Now, when we read that, so this is how the data is displayed. As address is a struct, it gets here age, ID, name, and order, the complete array is read into this column. So first we will process the struct field address. I mean, there is no hard and fast rule that you have to first do this. You can also do first this, or you can also do everything together also. It doesn't matter. So only logically, I'm just trying to explain. So that's why I'm first handling the simple ones like struct. So first we split this because it is a struct. Then we read address dot with the dot notation, address dot city, address dot state, and address dot zip. And then we are dropping the original column. We don't need it because we already have split it into 3 columns. So here we get ID, name, city, state, and zip. Orders is still left as array. So next what we do, since it is an array, we will explode it. Exploding means it will convert, do into multiple rows. One row into multiple rows with as many elements we have here. So if we have 10 orders in this column, so the row number 1 will be duplicated 10 times with information for each order in one row. So if it has 10 rows, 5 orders, it will be 5 rows. 100 orders, it will be 100 rows. 1 order, it will be 1 row. So since we have 2 orders here, so when we explode orders, so you will get orders in each row, 1 order in each row. Again, it's still in the struct. And then we drop the original orders, which is an array. So once we got this struct, again, we know we can split this into columns using dot notation, order dot order ID, order dot product, and order dot quantity.
You got the struct, but at the same time, another observation is if you see the rows have exploded.
Yes.
You see 31, 31.
Have 2 rows here.
Sahil, you see 2 rows. Earlier, only 1 row, which is still in array.
Yeah.
The explode is not only it opened up that the struct, but it exploded into multiple rows without doing anything.
Yeah.
If you
Each
see,
struct will be in one.
yeah, this will help you to get some code here and there. This exercise is to help you to navigate. You don't have to be 100% comfortable. Just to try to understand how we are doing it. Imagine doing this in general programming. I'm pretty sure, DK, you can comment based on your experience. If you have to do something in general programming, since it is a framework, Spark, it has all these higher order functions like explode and other things.
Right.
So they are helpful functions for you, right? And trust me, you'll have at least 10 to 15 examples anywhere you search, either in Medium or Google, anywhere. So if you follow basics, even a lot of things you can figure out as at least the basics if you figure based on your use case. How does it sound, DK?
Yeah. You got to write your own explode function if it is not there, right? I mean, in general programming sense, right? It has to, you got to loop in and, and while you loop through every structure within the array and all that, right? Yeah. So this one function, one line of code is doing that for you.
Correct. We'll share even Databricks is even going to simplify this even better. They're coming up with some new functions, even to reduce a lot of button. But go. I think you guys are doing great. Just keep Sahil. Do you get? I hope you're learning something here. Right?
Yes, Amy. I just want to ask question to Harun. Whatever we are using this data frame, can we also use Spark SQL to flatten the data?
Yeah, definitely. It will be the same syntax instead of with columns, and then you select. Either you select from direct data frame, as Shiva has said, you can select in Spark SQL also directly from data frame, or register the data frame as a table, and then you just say select order dot order ID as order ID. You can simply do that.
Okay.
It's the same thing.
Harun, I have a question.
Mhm.
So if you just look at the orders part, right, within the array that we have a 3 records,
Yeah.
okay, which consist of the 3 columns. Let's say one record, if I'm taking an example of ID1, has a 4 columns, whereas the ID2 has a 3 columns. So how does it going to be reading out? Like
That's what we mentioned, right? It will be null for that. So
Yeah,
if you
that's
okay.
what.
schema, if you enforce schema and give, so let's say this product does not have quantity here. Okay.
Okay.
But
Okay.
if you say quantity you read, but it is optional, not mandatory. If it is mandatory, it will throw error. Something mandatory is missing. If you say optional, it will just put null there, that it is not available for that record.
Gotcha.
When you're defining the schema. Okay. Okay. I think we are comfortable with this. So I just want to show one more where you enforce the schema here. Basically, it's the same JSON file. Instead of file, I just defined it here as data. It has same element called data, employee ID, name, and awards is an array. And within that, it has a structure. Okay. So how you define the schema is the struct type dot add. So what are the elements in the struct type? First thing is data we wrote here, which is again a struct type. So within the struct type, we have employee ID, employee name, which are string, and then awards, which is an array. So we added awards. It's an array type. Within array type, the inside structure is again struct type, right? Array type of struct type. And then we have award type, award name, and year as the attributes. These are strings. So this is basically you are trying to define the structure of your JSON, right? So just like your schema, your table schema, when you create, you will say create table like this. Name is a string, salary is long, decimal, whatever it is. So same thing, you are trying to define the schema here. So struct type, and within that, this is a struct type here again. Inside you have 2 string types. Awards is an array, and within array, you have a struct type, and within that you have this award type, name, and year. Got it? So you're just now reading this data using this schema.
He is trying to create the schema is so that in future, if you need to change the schema, you have control. That is the whole idea, guys.
Yeah.
So when you read it, it will have a default schema. But no, you might, when it reads, it may not accurately does the schema. Sometimes it's the long, but you want that long to be an integer, or something like some other, you want to cast it. So for the whole structure, you need to create the schema. So that's where you need to understand how your JSON file look like. And based on that, he is trying to create the way he want. So when you go to your use case, your business may come up with this is a schema, but when you write it, this should be your table should be like this. This is the data to make sure you enforce it. So that way, schema is enforced. That is the whole idea. just giving the sense why he's doing it.
So is data and schema or keywords, and you just used your variable names also as the keywords? That's why you
No,
have data.
data is not a keyword. Data is not a keyword. Data is a variable. Can you go up?
So in the bottom, he said create data frame, data equal to data.
Exactly. The data is he's constructing. First data is keyword,
Yes.
but the second data is not keyword.
Right, that's what I'm saying. Yeah, okay.
No, that's a good point. Yeah.
So you can use the keywords as variables in Python.
Yeah. This is something, like this, if you do.
So this schema is optional thing, right?
Depending on the need. Generally, generally when you read it, it appears it is given a schema. But even there is a, say, 1% wrong, the way it interprets. Many times you don't want, it shows us strings, but you want a schema the way you want. That is the.
Okay, got it.
It's here. What I was trying to check earlier. Basically, see, this is the original schema that we mentioned. And then oops. Okay. Okay, I'll just put something here. Okay. So basically, this is what we did. And we parsed this data, right? So it is all good. Now, I said, what if one column is missing? Okay. So let's say this, I don't have year here. Okay. And I have still defined it in the schema because here I have year. Okay. So if I run this, it will not fail. It will just read it as is with null here. See, it is null. Now, if I say nullable is false, so I say this field should be mandatory. I should get this value. Okay. Now I don't have it here. Now when I get this is when it will fail. It says field year in array field awards in field. This field is not nullable, but got none. So if
you're forcing DK.
Forcing the schema, saying that,
so that if you get a wrong data,
fields,
you stop it.
Yes. You can basically write your exception handling here.
Yeah, exception handling.
Yeah, and then say, okay, some issue with the data, I'm rejecting this file or rejecting this record, whatever you want to do. But this is how you have the control to check the schema, whether all the data is coming as per the schema that I mentioned. What are my mandatory fields and what are my optional fields? So this nullable, false and true will give you a control on how you validate the input data. So if you just say it is nullable, then it will go through, it will just add null to the data. Okay. Yeah, so that is
exception handling.
Yeah.
So is it pertaining to only the schema, the definitions, or does it also pertaining kind of data types as well? Let's say we have defined some data types, whereas we have the inputter has given a different type of a data. So in such cases, how does we are actually identifying those issues?
So it will still, if you give string, it will still take it as 2000 as string. Okay, so that's what we said, right? It is a compatible. Now, if I make it here as integer, and then I give here this. Now it fails. It cannot accept this into integer. So basically, it's another exception that it will throw. You have to handle. So anything to enforce. Now you have choice what you want to handle. So you want to handle the data types. You want to handle the optional versus mandatory. Anything you can write in the exception handle. So you get here it is type error. Earlier you get a different type of error, right? So you can check for that particular type of error, handle that, and then take action what you want to do.
It is like a general create table, Hari.
Yeah.
In a create table, you create data types, right? So it means you are expecting data to be compatible, correct?
Yeah.
So it's the same way. Just here that schema is nothing but you're enforcing something. So you will know in the discussion, your team will say, hey, this is the schema. Of course, 99% you'll get the same data. That is to capture those exceptions. If by mistake someone sends wrong data, so it won't happen. It comes from a protocol, right? See, suppose you are coming from Hyderabad to US. You are expected to have a visa. There will be checks, right? In the airport, there will be checks. Even for that matter, why even you come to the airport, correct? Without passport, you won't come, right? It means there is an agreement with you. Hey, come to US, make sure you bring your passport, and make sure you have the stamping. So like that, with the source system that is sending, they won't send randomly. It is not like that, there will be a protocol. Hey, this Kafka is sending it. So there are options, if this happens, drop this record, something. But that comes under practice. There will be a lot of helps available. There will be discussions how to handle it, all those things. So focus on the core thing. Hey, what is this exactly? So I have a lever, I have a control. I am coming some data. I'm enforcing a schema. Schema is something you enforce. It is just like your table schema. Table, when you create table, you're enforcing it. You're saying, hey, I have the container. This is the table. I expect this data. If you try to insert, it will say, your table says, no, hey, this is the wrong data type. Anybody wants to add any comments?
Yes, I just want to add some couple of points. So at least from my experience, so what I've read is like 90% of the time we define the schema just to avoid any unnecessary errors. Like sometimes Databricks might not infer the schema. Like sometimes it has a null value in the column. It might treat as a string, and date especially comes as a string.
Right.
So it's always recommended to define the schema. The other important point is it improves the performance because every time the system doesn't need to infer the schema because it knows what is the data type. So that improves the performance. So usually we add all the.
That is fair. So it is not just you decide. It's a common protocol, right? To say, hey,
Best practice.
we are having schema. Can you display this? I shared you one link, Harun. That is correct, Lakshmi Prasanna. That's a good point. I shared your link in Zoom chat, Harun. Can you just display that? See this, guys. In Spark 4.0, right now Spark 3 point something coming. So a new development is going on. I don't know how perfect it will be, but see the heading. Can someone read that? The heading in the sense that in Spark 4.0, yesterday somebody posted.
Yeah, in Spark 4.0, there are no more data types mismatches when converting dynamic JSONs as the new data type variant type comes with a new function to parse JSONs. Oh, that's a good feature.
So stay tuned, but at least they're giving a, peak. Oh, it means some improvements are going to be there, right? But in any case, your point is valid. Based on the project, you just don't decide. This is the project. We are doing a schema, and what is the schema? You work with your team. You find a schema. You just apply the schema. That's it. Sometimes even it is not only JSONs. Even some regular files, or even Parquet, sometimes you read, you convert some data types to another data types. So you might put a schema, even though there is a schema exist. So, but anyway, I think just take it easy. I think this is a learning. In 1 hour, you will not have all answers, but you can do some research on it, take it, have some inspiration. Oh, okay, I have this, yes, and I'm reading it. And play with it, and spend some time. You'll have even more insights. Hari, how does it sound?
I will publish the sample files as well with the recording and notebook, so that you can use the sample files to run this notebooks.
Hari, how does it sound?
Yeah, it's good. It's good.
Prasanna?
Yeah,
Get some name?
sorry, yeah. Can I?
Yeah, go ahead.
Yeah, so just we spoke about certification, right? This is one of the important points, like what we covered in this class today with Harun. Concentrate on this array part, keep practicing, especially explode and flatten. We might expect some of one.
Exactly. You know how to prepare for exams, Lakshmi, Prasanna. I know you are exam-oriented person. That is really good.
I want to help, because when you get that thought right, then you will spend time to work on that. So practice this part today.
That is good, guys. There will be some questions clearly in the syllabus. They mentioned handling JSON. This one already, Prasanna knows the syllabus by heart, I think. But that's good.
And just one small thing, I posted here, I think Harun asked, I was not there. So I posted all the links which I have used it. Maybe if I want, I can put it in the WhatsApp also. Just go through this once, just keep listening to that. Initially, you might feel a little difficult, but once you keep listening and understanding, you will get hold of that.
Yeah, sure. So maybe you can post that to practice group. There is one practice group that created, right?
I am not part of that, I think.
Oh, that's fine. Yeah, I can put it there, or probably add it to our running document at the bottom.
Yeah, that would be. That's it, Singh. Thank you.
But good discussion. Check with everyone how they feel. At least they get this good sense to move forward.
Yeah, sure.
Okay. Yeah, I got basic understanding of JSON today.
Sure. Great. Thank you, Nag. Subbu.
Yeah. So in the when I used in the other applications JSON, I know, but in detail I didn't know like this. You explained very nice. So never forgettable. So very nice.
Good. Yeah, thank you. So who else we have? The other Pawan, we good? Purnima, Satish.
Yeah, I have one question.
Yeah.
So you mentioned exception handling, right? Say if we have 1,000 or like maybe 1 lakh records, JSON records, and once it starts reading, suppose on a 70,000th row, if some data is null, is there any way that the programs can skip that row and simply proceed with the other things, or it goes for exception handling and you need to do the reading from the beginning again? Or...
No, you can.
DLT, there is an option to drop those records. Or comment.
Oh, yeah. Go ahead, Srini.
No, there are options. If it doesn't meet, drop this. There are some loops. You'll get to know.
Yeah. So it's just like any other programming language, right? You process the data row by row in a loop. It's the same thing. It happens in a data frame. Your functions run on each of the row, right? So when there is an exception, you have an option to skip that row, or you throw exception and come out of it. So there's always a soft asset and hard asset that you want to do.
Okay, we have the option to skip that, right? Yeah, that's just wanted.
Okay. Yeah, Satish, Ra.
Yeah, I'm good.
Okay. So we have Venkat. Venkat, I think, is joined from India. And that's fine. Okay, so that's the discussion regarding the JSON. So we have another small topic called UDFs, user-defined function. I'll just give you a brief understanding and discuss a small topic for today before we wrap up. Okay. So user-defined functions in PySpark, basically it's just like you're defining a function to run on each row of the data frame. Just like a Python function. So when you talk about data frame, we know that, right? So it is distributed. It's not running at one place. So it's distributed across multiple nodes. So whatever function you want to run, it has to run on the data on all these nodes. So when you run any function on the data frame, it's not like you can give a scalar value, just single value. Everything has to be a vector or something like distributed. So when you do a function, it gets distributed to all the nodes to run on the data on each node. So basically what you do when you define a function called, say, calculate birth year, and then you want to calculate this for each row of your data frame. Okay, so you have your employee file, which has ID, age, and gender, salary, experience. So you want to define calculate birth year. Birth year is, say, current year minus age. So once you define this function, this is a Python function here. There's nothing related to Spark or data frame. So you want to run this on Spark SQL or on the data frame, right? So what you have to do is you have to register it using UDF. You'd say user-defined function, and then you give this is the syntax. You give the function that you have defined here, and what is the return type, what it is going to return. It's going to return an integer. So once you register this as UDF, this function you can use directly in your transformations with the data frame. So you say with column here. Remember last time we were doing some calculations based on directly here. It's like you can do the 2024 minus df of age kind of a thing here. But the same thing, it's more performance optimized if you do a UDF, since it gets distributed and runs on the data frame. So
so you mentioned like we need to while registering the UDF, like we need to mention the return type, right? So no need to mention the input parameters. Here we are just passing age, or
not the data type, just the number of parameters. Normally in any of the Python functions, you don't give the data type. It is automatically inferred. So it's just the how many, when you call the function, you have to pass the correct number of parameters. Otherwise it will error out. But here you just provide the return data type.
So in UDF, we need not, in UDF function, we need not mention the number of parameters. We just need to
no, just the
mention the name of the function.
Yes.
Okay.
So, and then you pass the parameters here and use this UDF function that you have registered with in the transformations. Okay. So you get with column, new column. So on each row, it is doing this, calling this function and passing this age of that row and getting you this. You can also do that using SQL. You can register same UDF function. You can use in the SQL as well. In my notebook, there is some issue I need to fix. So I'm not using this, but yes, you can also do this. We'll check on that. But with the data frame with column, this is how you use it. Birth year. So if you want to define something else, so I have done here, basically how you do. I want to calculate a bonus on this. So I declared a function calculate bonus. I'm passing 2 parameters here. See, Pawan? But I'm not say registering in the UDF. I'm not registering how many parameters, what data type I'm passing. And again, I'm saying it returns a integer type. So I defined salary into what is the bonus percent divided by 100. So we're registering the user defined function as UDF of what is the function name and return type. So when I'm using this with column, so column name I'm using as new column as bonus. I'm calling this function user defined function calculate bonus DF. So I have to pass 2 parameters. First is the bonus percent. So I don't have it in the data frame. I'm just saying arbitrarily do 10% for everyone. So I pass literal, literal can be a number or string. So you cannot just pass a scalar value like 10 here because it is a data frame. So if you do like this, it will throw error. So you have to define literal as a column. It will take as a column with value 10, and that is what it will pass for every row. And DF of salary. So if I run this, so it will throw errors. Basically, you add this 10% as a literal function.
So to use that literal there, you need to do that first line code or line of
import.
code.
Yeah, import from the function.
You also did this for UDF also on the top, right? On the previous block.
Yeah, you have to import UDF and integer type. So whatever type you're using, if it is a string, SQL types and functions, not for just UDF. If you observe all our previous transformations also, wherever we are using, we are downloading, importing those types from Spark SQL types and Spark SQL functions. So if you see even the JSON file we did here, see, I just said import star. So it will get everything, all string type, integer type, everything. And you can also do functions dot star also if you don't want. So here I imported only column from functions. So you can import whatever you need, or you can just leave it as star. As here I imported explode from functions and column. Okay.
So the scope of the import is for this notebook, like anything below the cell.
Yeah. So it's basically within the, it's the notebook. So if I execute this cell, it will still be available for the subsequent cells. If I don't execute this and directly execute this, it will still throw error because it does not know.
Okay, got it.
Yeah, because here I put import star and then run this. So all subsequent cells, whatever types you use, it will already be available.
So the import star will import everything, right? You don't need to really do that import.
Yeah, you don't need
COL
to. Yes. Yeah, whatever you need. Just say.
No, on the bottom, right? You still imported few things, right? Like COL and stuff like that. They are really not needed. See there, right?
This is functions, not types.
Okay.
Column is part of functions library, not types library.
Okay.
I imported that.
It's like function means Java or anywhere in C, C++, we define function and we can call in the defined like package. So we can call it, right? And it will return whatever the value it has the
Yeah.
function. Same thing.
Yes. Yeah, that function is actually in the sense that you are defining your own function in a class or in a method,
Yes.
what you call.
Yes,
Here
you're
it is a
right.
library. PySpark.sql.functions is a library in which you will have all of these functions to use. Explode, column, whatever, all of those. So there are two libraries that we use: PySpark SQL functions and PySpark SQL types mostly. There are other ones also, but based on what you need, you can import that.
Okay, got it.
Okay. So that is basically the UDF. It's a simple concept. You just define your Python methods and then register it with UDF and use it in the transformations or in the Spark SQL. Okay, so if you are using any scalar value, constant value, so you have to use with lit. So lit can take multiple things. Again, it can be a number, it can be a string that you want to pass. That also you can pass with this. Okay. Anything else?
Are there types of user-defined functions, Harun? Like, is it like a scalar function versus a table-valued function?
Yes, there are some like something it's called data frame. So the pandas UDF versus scalar UDF. So there is something called pandas based UDF also. I can check the syntax. Yes, that's the table format UDF. That's available. Okay, I think so that's all I have to share today. If you guys have any questions, comments about how we are doing. So it's like, yeah, the long weekend is coming, so we'll be taking a break until this weekend, next week. So we'll have the next class on next Saturday. So almost after 10, 8, 9 days. So you guys can go ahead and practice. So before going there, you can take it as, the first part or phase 1 of the session of the training. So where we did basics, what is Databricks or what is Apache Spark, what is a data frame, what are different sources of data that we can read, ingestion sources, CSV, JSON we covered. It can be a database table that you can read from. What are the transformations, actions? We covered lazy evaluation, how the instructions are chained, what happens, how it runs when we do a action on the data frame, how or the Spark internals basically, how the data is distributed in multiple nodes. We did Spark joins. What are different types of joins we can join? We did Spark streaming also, streaming from files, streaming from the range functions. In future, we'll try to do streaming from Kafka. We'll have to do a separate installation possible based on local system. We cannot do it using community edition on the cloud. But yeah, we did some part of Spark streaming basics. We did the caching, how caching impacts, where you should cache. We did joins, and then we did join strategies, how Spark does join strategies like broadcast, shuffle join, sort merge join. When is it useful? Then we did partitioning, repartitioning, and coalesce different memory types, basically the caching types in memory or disk, a combination of it. What else? What else did we do? Anyone remember? We did more. We did DAG, Spark DAG, how where the shuffle happens, how the jobs are created, how the stages are created, where the boundaries when the shuffle happens. In what scenarios does the shuffle happen? Like you do repartition, or you do group buys, or you do joins. So those kind of scenarios, we said the shuffle happens, right, in the performance. So I think that is all I could recollect at high
Cache
level.
and persist.
Yeah, cache and persist. Yes, you mentioned that at different types of caching modes, basically, you can say, and writing to different tables: bronze, silver, gold, the medallion architecture, the concept of reading and writing, the file formats, the Parquet format we did. We touched upon the Databricks Delta format as well. So I think that's what we all covered in the past few weeks. And going forward, yes, we'll get deeper into more of the Lakehouse concepts, since we covered the Apache Spark basics processing. So we move on to different topics when we come back, more like Databricks Delta. So what are the features? For example, like time travel, vacuum, optimize, how Delta manages the transactions, the transaction log. We'll look into that, the time travel concepts. Then probably the how we do the pipelining or the workflows, DLT, or how DLT works.
Let's also align to certification.
Certifications.
Covering all
I mean, we'll cover some basic concepts, but yeah, we'll see how we can align more to getting the certification process.
So next Wednesday, there are no session, Sat.
Yeah.
So take good rest, or if to get time, just brush up. But
Okay.
stay positive. It's a great work. It takes time, but trust me, it's coming up good. You feel really, really comfortable as you move. Hard work will pay, definitely. Hard work pays, and we are there to help you. How do you feel overall? Let's wrap it up.
I want to take the feedback, how you're feeling, how
Stop sharing, Harun, so that you can see here. Yeah, let's check, pulse check. Sahil, how do you feel? Subbu, Purnima?
Yeah, a good training. Very informative.
Purnima, you
Yeah.
feel encouraged?
Yes, it is good training. I have a bit of experience with JSON, so I'm able to follow through. It's good.
Super. Were you .NET, or what's your background?
SQL Server developer.
Oh, super, super. Shiva, DK, how do you feel?
Good, very good. I mean, a lot of things you covered.
Excellent, excellent. Nothing is perfect, but going gets tough gets going. Akshata, Prasanna Gattamaneni, how do you feel?
Yeah, I feel good. Amazing session, Harun. I really liked it.
Super, super. Venkat from Hyderabad. Hari, Hari and Nag.
Yeah, it's good. The way Arun is explaining was very well. So it is giving me a more insight to understand. I mean, from the scratch. Yeah.
Yeah, you feel comfortable. See, the idea of the trainings are not, oh, everything you can learn here. Please understand. The idea is to put a foundation and move forward. And okay, I know these basics. I can able to refer this. I can able to grasp these things. I can able to tie. That is the idea of the trainings, guys. Super. Nag.
Yeah, in my current job, I support convergent mediation system, which is Java based. and all the users groups roles are in JSON. When we download, it comes under JSON format. And then I need to get developer. I need to go to developer to read the data. Now I know how to read it. I think I should be able to read myself.
Super, man. Okay. Get ready for the double the fees, okay?
Yeah.
Super. Good
Please
job,
don't-
Lakshmi Prasanna. Keep inspiring the team. Continue, Nag. You're saying something. Sorry.
No, don't triple it. Okay.
Okay. Yeah, Lakshmi Prasanna, keep inspiring the team. Keep sharing the knowledge. Encourage others. Always trust me. If you encourage others, you will be encouraged. That is the secret of life. Nothing else. You encourage others, you'll be encouraged 10 times. Subbu, you feel good? Do you feel you have team support? You're not alone. Subbu.
Yeah. Yeah. So something
Yeah.
else. Okay.
Subbu? Yeah. You're on mute, Subbu.
Yeah. Yeah, it's a great experience. So it's a good class. So technically,
You need
so
to put effort,
basics.
Subbu.
Yeah, sure.
Market is,
Sorry.
trust me, market is very competitive. Thanks to this technology, there are a lot of jobs. But the expectation is a lot, trust me. Because the rates are very high. So automatically customer expect a lot. So you need to, if you focus, you'll absolutely get into a good career next 5 to 10 years for sure. Even as other Nag mentioned, you're not just learning Databricks, trust me. This is an open technology. Reading JSONs, reading Spark is an open source software, first of all, try to understand. So if you go and do Fabric, 80 to 90% is the same. If you work on Snowflake, they have even Snowpark. They customize Spark a little bit. It will absolutely the same. And if you work on Amazon, even Salesforce, they have Lakehouse. Even if a company build your own Lakehouse, 80 to 90% is the same. So this is an ecosystem. So it is not just, it is one small skill which will be outdated. No, this is a very open data and AI platforms. There were a lot of platforms, but now all are getting consolidated to open architecture. Here, if you see, all storage is in the cloud. Your compute is separate. And your computing framework is Spark, which is an open source. So what Databricks did is they did a package it. That's it. They did package it, the security, and put it in the cloud and giving some tools, etc. Notebook is also open source. I don't know if you know. If you there are a lot of Python notebooks. They follow the same stuff. Right?
Yeah, it's part of Anaconda.
Exactly. So and this can be even done in editors. There are a lot of things, and it's a distributed computing. It's amazing. Even we get inspired, even after spending many years. Still, I feel fresh. This is good stuff. When you're doing good stuff, you are motivated, and spending time is worth, and you get the return, you get the money. And on top of it, you are relevant in the job, or people respect. Of course, there will be always challenges. There will be ups and downs. That is always there. But it's better to have good ups and downs in a cutting edge career. So it's good. We have Harun. We have everyone for each other, and we'll help you. But encourage each other. Start sharing your knowledge. Probably from next week onwards, even we will give you some topics where you need to present some 10-15 minutes. So otherwise, great. Anything else? Anyone? Feel good? DK, Sahil?
Yes, sir.
Okay.
Yeah, it's all good, Srini.
Super. Shiva, I'm going to work with Shiva. Shiva, you need to help our team on the data modeling. You're expert in the data modeling.
Sure, definitely.
Data warehouse.
We have prepared something, yeah.
Yeah, we'll work. Okay. So Pawan, DK, everyone, Good job, Harun.
Yep.
Mhm.
Thank you. Have a good.
Thank you.
Thank you,
Super.
Arun. Thank you, Shiva.
Encourage
Thank
each
you.
other. Encourage, help each other. We'll grow together.
Yeah. Thank you.
All right.
Super, guys. I'm very
Have a nice
excited.
weekend, long weekend. Take
Yeah.
care. Enjoy.
Yeah.
Thank you.
Thank
Okay.
you.
Take
Bye.
care, guys. Have a safe day. Bye.